In this video, we're going to look at arithmetic sequences. So we're going to work out the nth term of an arithmetic sequence. So we've got 5 terms of a sequence here, which is 3, 7, 11, 15 and 19. So what we're going to do for a question like this, we're going to say, well, what do I add every single time? So I can notice that I'm going to add 4 every single time in this question. So plus 4, plus 4, plus 4. This is known as the common difference. So to write down the nth term, you write the difference, which is 4, write an n that's next to it. And then what we're going to do, we're going to take the first term and minus the difference. So minus the difference, as in do the opposite of what we have. So it's going to be 3 is the first term. The opposite of plus 4 is minus 4. So 3 minus 4 is minus 1. So we get that the nth term is 4n minus 1. This is called the nth term of an arithmetic sequence. So now we're going to say Adil says that 319 is a term in the number sequence. So is Adil correct? You must justify your answer. So what we do for a question like this, we take the nth term, which is 4n minus 1, make it equal to 319. We're going to add 1 on both sides of the equation, and what we'll end up with is 4n equals 320. So we can divide both sides by 4, and we get that n equals to 80. So we'll get a whole number. So the answer is Adil is correct. So Adil is correct. And we could say 319 is the 80th term of the sequence. It's the 80th term of the sequence. Here's another example. So the question says we've got 5 terms of an arithmetic sequence. Find the nth term of the sequence. So we're going to say, well, in this case, we're adding 4 every time. So we do plus 4, plus 4, plus 4, plus 4. So we write 4n. And remember, we take our first term, 3. That's our first term. And do the opposite of the difference. So the opposite of plus 4 is minus 4. So 3 minus 4, that gives me minus 1. So I get 4n minus 1 is the nth term of this sequence. Then the question states, Laura says that 412 is a term in this arithmetic sequence. Laura is wrong. Explain why. So we do 4n minus 1, that will be equal to 412. We can add 1 on both sides of the equation, so 4n equals to 413. But I can't divide 413 by 4, I'll get a decimal. So I would say 413 is not divisible, so it's not divisible by 4. So 412 is not in the sequence. Is not in the sequence. Therefore, Laura is wrong. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we've got 5 terms of an arithmetic sequence. We want to write down the nth term for the expression of this sequence. And further, it states that Pat says that 453 is a term in the sequence. Pat is wrong. Explain why. So let's do the nth term first. So what do we add every time? In this case, it's 4 again. It doesn't always have to be 4, but in this case it is. So we're adding 4 every single time. So it's going to be 4n. Then we take our first term, which is 7, and do the opposite of the difference. So that's going to be 7 minus 4, which is 3. So we get 4n plus 3, and that's going to be the nth term of the sequence. So to check whether 453 is a term in the sequence, we equate it to the nth term. We're going to minus 3 on both sides. And we can see that 4n equals to 450. But 450 is not divisible by 4. So we're going to write that down. 450 is not divisible by 4. Not divisible by 4. So 453 is not in the sequence. Hence we can say Pat is incorrect. Pat is incorrect or is wrong.